All right, so chapter 4 class notes in our shared drive. Please go there now and grab 4.1 class notes. So what we used in class last time was 4.1a. I went ahead and combined A with B in these 4.1 class notes. So I'd like you to grab those right now. And at the top, you'll know that they're different because they'll say A and B. Now, all of the content is the same for part A. And we're going to quickly go over and finish part A first and then do B today in the course of a couple videos. So let's go ahead and get started. Pause the video, and when you've got your class notes 4.1 AB up in front of you, we're good, we're ready, let's do this. Alrighty, so by means of quick review, again, depending on which section, you might not have these exact same notes written on top of your 4.1a notes, but when we say convert, it means we're going to be multiplying by the appropriate unit ratio. So again, what's a unit ratio? It's any fraction where the numerator and the denominator are equivalent amounts, but measured in different units. So 12 inches over 1 foot is a unit ratio. I could flip it upside down and say 1 foot over 12 inches. That's another unit ratio. I would use this if I were going to try and convert between feet and inches. Pi radians over 180 degrees is a unit ratio. 1 minute is 60 seconds, right? That's a unit ratio. So what we covered in class was converting between degrees to degrees, minutes, and seconds, right? So there's a little bit more work there. So if when I went over this in class, it was a little confusing, again, the goal is to convert. So whatever unit you have is going to go in the denominator, and whatever unit you want is what needs to be in the numerator as you're doing your conversions. So degrees, minutes, seconds, bearing, or a course of an object is the angle from true north going clockwise. Northwest is halfway between straight north and straight west, so 45-degree angle that way means a 315-degree angle all the way around. North-northwest, right, is halfway between north and northwest, so halfway between this 45-degree angle. So half of 45 is 12 and a half, right? And so again, but bearing is measured clockwise from true north. You're going to see that in some of the word problems we're going to look at today. So it's good to be reminded of our textbook's definition of bearing. And then again, understanding how to convert between radians and degrees. If you remember and have memorized this equivalence, that pi radians is equal to 180 degrees, then the unit ratio you're going to use when you're converting between radians and degrees is either going to be pi radians over 180 degrees or the reverse of that, 180 degrees over pi radians. Again, a radian was the angle necessary in a circle to trace out a arc length of r, the radius r. I don't know why that word does there. All right, so radius r, arc length, how the central angle that measures that is 1 radian. So again, when you think about what's the circumference of a circle? The circumference of a circle is 2 pi r. So there's 2 pi of these arc lengths r. So that means there's 2 pi radians in 1 revolution in a circle, right? So since there's 2 pi and 360 degrees, there's 1 pi and 180 degrees. And this is the unit ratio you're going to be using. We never talk about 1 radian equaling 57.3 degrees, or 1 degree is pi over 180 radians. We generally don't think about that. We think about this unit ratio. Also, and so this is where we stopped in class. So moving on after converting between degrees, again, thinking about this central angle, right? The central angle of 1 radian traces out an arc whose length is 1 radius. So a central angle of 2 radians, right? Swoosh, swoosh, right? That's going to have an arc length of 2 radii, 2 radiuses. We don't say radiuses, we say radii. A central angle of 3 radians has an arc length of 3r, 3 radii. So in general, if you've got an arc length of theta radians, that arc length is going to be theta times r, right? Do we see that pattern there? So another way to think about this, truthfully, the way that I remember it and the way that I think about arc length, because this is the formula that you're getting for your arc length. Your arc length is the radius times the angle in radians. I personally have always remembered arc length as it's a fraction of the circumference. All right, so arc length, I'm just going to write fraction of the circumference. Fraction of circumference. Right? And so what's your circumference? Your circumference is 2 pi r. And what's the fraction? Well, it's theta over 2 pi, because there's 2 pi radians in a whole circle. But I only want theta radians of it. Well, then we can clearly see the 2 pi and the 2 pi cancel out, and you've got theta times r, right? So if your central angle is measured in n degrees, right? So n degrees, well, I got to convert that to radians then. So n degrees is pi radians over 180 degrees. So the degrees here will cancel out. And you're going to have n pi over 180 radians. Well, that's my angle theta. So that's what I'm then going to multiply r by. Or again, if it's in degrees, I would just write it as, well, n degrees over 100, not over 100, over 360 degrees is the fraction of my circle times 2 pi r is my circumference, right? And what do we notice? The 2 and the 360 divide out, and you're going to have 180 left down here at the bottom. So you're going to have n r pi over 180. And again, the degrees units here also cancel out. So arc length, fraction of a circumference. And that's going to help you when you are trying to think about areas of wedges of circles also. It's a fraction of the area of a circle, but we'll get to that. First, let's look at example 6 here. And so again, the work is all here. I've just doctored it up a little bit more and shown a little bit more work of how I would do this by hand. So in a circle with radius 36 centimeters, determine the arc length of a central angle that has a measure of 4 pi over 9 radians or 150 degrees. So 2 separate problems, but what are you going to do? Well, again, 4 pi radians, what's my arc length s? Well, according to our simplified formula, it's just r times my radians. So my radius is 36 times my radians, right? 36 over 9 simplifies to 4 over 1. 4 times 4 is 16 pi centimeters. So that's the exact answer. And then here's your decimal approximation. 150 degrees. Again, 150 degrees. If I convert it into radians, then it's just my radius times the radians. And so that simplifies to 30 pi centimeters or approximately 94.2478 centimeters. All right, let's look at a few more examples and finish up part A. And then we'll look at a few more new terms. So DC's doctor quarters, Leadfoot, right? I drive really fast. But DC Leadfoot's car has wheels with a 30-inch diameter. All right? So DC's a guy, apparently. His wheels are rotating at 800 revolutions per minute, RPM. Determine his car's speed, specifically in miles per hour. Alrighty, so here's what you need to think. How fast is his car going? 800 revolutions per minute. So right now you have 800 revolutions over 1 minute. You need to convert this. You need to change these minutes into hours, right? Because I want miles per hour. That's pretty easy. There's 60 minutes in 1 hour. How do I know that I want minutes up top and hour down below? Because my final answer, I want miles over hour. So I want hour down here. So I want my minutes to cancel out there. Now, revolutions, I have to change revolutions into miles. So I need to think about what is the distance of a revolution. So again, if you were to draw paint, if you had paint around your tire, your wheel here, and it started to roll, right? 1 revolution would be equal to, right, that flat distance there on the ground. That's the paint that would roll out on the ground. That is your circumference, C. So 1 revolution is the distance of a circumference. And what's the circumference of a circle? 2 pi r. So here's your 2 pi. What's my r? If it's a 30-inch diameter, it's a 15-inch. So you could do, there's 2 pi radians in 1 revolution. Well, and 1 radian is 15 inches because 1 radian measures out 1 radius's arc length. But for me, again, I just keep it all in 1, so I wouldn't even put that there originally. So 2 pi r, so 1 revolution is going to be 2 pi r inches, because that's the distance, right? And now, again, I'm trying to get to miles, so I'm going to convert from inches to feet and feet to mile, punch it all into your calculator. There you go. All right, some new terminology, or what might be new terminology for you. A nautical mile. Okay, so I Googled some images that I want to share with you first, right? So a nautical mile. So first of all, this is in meters, the metric system. We're going to use the US system, but here's the idea. The distance along the surface of the earth that is 1 minute from the core of the earth. If you were to measure out 1 minute, again, what's 1 minute? It's 1/60th of a degree, right? 1 minute. This distance right here is what we call a nautical mile. So coming back here, right? A central angle of 1 minute intercepts an arc on the circumference of the earth's surface, right? Whose length is a nautical mile. So now the average diameter of the earth is 7,912.18. We call them statute miles. What is a statute mile? It's a mile when you drive in your car. If you had to run the mile for PE, right? A statute mile is mile. So nautical mile is a different type of mile. And again, what is a nautical mile? It is the distance that 1 minute measurement from the center of the earth would trace out along the earth's surface. So there's some current conversions you can quickly see. Notice here a nautical mile given in feet and a nautical mile given in feet are slightly different. And that shouldn't be too surprising, because if I'm measuring something based on the surface of the earth, well, is the earth a perfect sphere? No, it's not. Because the earth is not perfectly spherical, right? We're going to look at the average diameter of the earth in normal miles, and therefore the circumference is your diameter times pi miles. So an angle of 1 minute is going to cut an arc that is 1/60th of a degree, right? Of 136 degrees in your entire circumference. So 1/60 times 1/360, 1/21,600 times your circumference is about, for this class, we're going to use 1.15 miles. So 1 nautical mile equals 1.15 miles. And again, if you're trying to remember, 1 minute, right, from the Earth's core is 1 nautical mile. That's kind of what we're thinking about in terms of what is being traced out. So example 8 and 9. Example 8, boat speeds are often measured in knots, right, which is 1 nautical mile per hour. So what's the speed of a boat in miles per hour if it's traveling at 15 knots? Again, you're going to turn this into a unit ratio. 15 knots is 15 nautical miles per hour. I want to convert from nautical miles to miles, so nautical miles should be in the denominator, so it'd be 1.15 miles over 1 nautical mile. Multiplying these together, you're going to get 17.25 miles per hour. All right, longitude and latitude. We're going to do example 9 and start the second part in our next video. But longitude and latitude, again, here's a Google search of that. So latitude is flatitude, longitude is long. So when I say latitude is flatitude, you actually should be thinking y values, right? So latitude is the angle from the center of the earth, right, from the equator, right? You can almost think of this as XY axis, but latitude are your up and down the earth's surface, and longitude are left and right, depending on where you are going to start. So the prime meridian is 0 degrees longitude. The equator is 0 degrees latitude.